Alright guys, welcome back. We're going to be solving question 43 from the second chapter of the Meriam textbook. We need to determine the general expression for the moments of f about point B and point O, and once we have that, we can evaluate our expression based on the values that we have for f, r, theta, and phi. So let's find the moment about point B first, and for doing that, let's call this one our x and y. And let's see if we can find the x and y component of force F. So this will be our x component and this will be our y component. So the resultant will be F. And in order to find these, we have to find this angle right here. And as long as we have that, we're good to go to find the x and y component of F, and it should be pretty easy after that to find the moment. But the question is how we're gonna find that angle. So we covered the trick in the previous videos in the channel that when we have two angles like this where each side of them is perpendicular to each other, so one side in here perpendicular to this one and the other side to this one, if that's the case, these two angles are the same. So now we have to figure these two in here and try to see if we can find these trick here to find the angle that we're looking for. The angle that we know as known is this one, which we know this side is perpendicular to this one, and the dotted line, the gray line in here, is perpendicular to this one. That means this angle right here is theta 2. So if that's the case, we have this line in here phi from the question, and the whole angle should be theta. That means this angle that we are looking for is simply theta minus phi. And if we add these two together, we'll get the theta that we have on the other side. So now that we have the angles, pretty easy to find the moment. And if we want to show the x and y component, we know we want to show it in red, then we can see it better, or black. So this force in here would be simply F times cosine of theta minus phi, and the other one here is F times sine of theta minus phi. Now it's much easier to find a moment since we have the x and y component. So let's start with the moment about point B, and we're going to call counterclockwise moment positive, and let's go with the x component first. So as we can see, the moment about point B is in this direction, which is a clockwise direction, so we have a negative sign in here, so negative F times cosine of theta minus phi. And now we have to find the r, which is basically what we have from here to here. And if we look at this right triangle that we have in here, since we know this angle theta and the hypotenuse is radius, so we'll simply have r times cosine of theta. So that was the moment of the x component, and we're going to go with the moment of y component, which this one also makes a clockwise moment, so that one would be negative 2. So we have minus f times sine of theta minus phi times the distance would be what we have from here to here, which is basically r plus r sine of theta. So this part is r sine of theta, so plus r in order to get it to point B. So that's pretty much it. If we put the values that we have for f, r, theta, and phi, we get minus 750 times cosine of 30 minus 15 times r, which is 2.4, times cosine of theta was 30 degrees, minus 750 sine of, again, 30 minus 15 times 2.4 plus 2.4 sine of theta, which was 30 degrees. So if we calculate this, we're gonna get a moment of minus 2204 Newton meter, and the negative sign shows the moment is clockwise. So that was a part of the question to find the moment about point A. Let's do the moment about point O, which is the B part. So that was the A. And again, we have the same thing. We have the moment of x and y components. So obviously the force is the same. So we have, let's start with the cosine first, or the x component. So I cleaned up the x and y. This is our x and y again. So the x component was f cosine of theta minus phi. Again, the moment about point O is clockwise, and the distance this time would be what we have from here to here, which is basically 2r plus r cosine of theta. So it's very similar to B, but we have like this distance 2r added to the previous part. And for the y component, which was sine of theta minus y, the force again is the same, and the distance that we have is exactly the distance that we had for B2, because this is the line of action, and distance from line of action to O is same as B, so not much difference in here. So r plus r sine of theta, and from here we can just substitute the numbers that we have, minus 750 cosine of theta minus 5, 30 minus 15 times 2r, which is 2 times 2.4 plus 2.4 cosine of theta, which was 30 degrees. And the second line we have 750 sine of 30 minus 15, and this would be pretty similar to what we had for previous part. So sine of 30 degrees, and if we calculate this part, we're gonna get minus 5682 Newton meter. Again, the negative sign shows the clockwise moment, and that would be the final answer for B part of the question, where we needed to find the moment about point B. So yeah, that would be all for this one. Please let me know if you have any questions. Don't forget to subscribe, like, and comment. It's gonna help me to reach out to more students. And you guys take care. I'll see you in the next video. Have a good one.